Hello and welcome. In this video, we're going to take another look at a demonstration of the software design method or software design process and our top-down design. This video assumes that you've been watching the earlier videos that focused on how we solved our flaky customer problem. In other words, we were given a problem to do only to discover in a later iteration of it that it was not actually what the customer wanted because we were interacting with the wrong person on the customer side. We got some additional requirements and then we ended up changing our entire project. And effectively, to mitigate against that, what we wanted to do is we wanted to change our design approach. Instead of putting everything in one function, we ended up breaking it up into multiple functions so that we could essentially accommodate that uncertainty. Now, again, there's many reasons why we do a top-down design. It's just merely one scenario. It does make for us a lot easier development, troubleshooting, testing, modularity, etc., etc. There are tons of reasons for it. But what I want to do in this video is I actually want to give us a graphical demonstration of our project. So this assumes that you've already got it working. As a matter of fact, you could see my output from the last video here on the screen. You can see where I've demonstrated that I can produce this little table, everything along those lines. Now what I want to do is I actually want to draw our solution out. So what I'm going to do is I'm actually going to go ahead and slide this over to another screen. I'm going to take it that you have already done this. If you want to copy and paste anything out to make it a little easier, I would encourage you to grab just your function prototypes because that's actually all we're going to be using. So I can either slide NetBeans out of the way or I can simply just copy those, for instance, over to Notepad. And essentially what I'm going to do is I'm just going to use that as a little cheat sheet so we don't have to bounce back and forth too much. Now, what I am going to do is I'm going to go to our draw.io that you've seen in an earlier video. You've actually seen some of the diagrams in an earlier video as well. Draw.io, app.diagrams.net. It's just a great diagramming tool that will allow for us to visually see how our code actually works. And my goal here is I'm going to take the two examples, problem 01 and problem 02, and I'm actually going to draw out how the code actually works so that hopefully you get a visual impression or a visual understanding representation of top-down design. So I'm going to go ahead and create a new diagram. I'm just going to go and do a blank diagram. We'll see how pretty we can make this. I'm going to call this one top-down design examples. And I'm going to already done a couple of these. So I'm just going to go ahead and call this one number 6. Seems pretty reasonable. Again, whatever you call it's perfectly fine. And I'm going to start by simply dropping our main on here, and we'll see exactly how much room we need. I'm not going to put a ton of text in each one of these blocks because I don't want them to get too big. I don't want this to be too obnoxious. But what I am going to do is I'm going to emphasize that this is our main. So the idea is that our main calls then our other functions. So again, what I'm going to do is I'm going to start off just with the function names and we'll decide what we need to add. And you again can leverage a little cheat sheet here, or you can just pull up NetBeans. But I already know that I'm going to have a problem 01, and we're going to put it maybe around here. We'll see. We'll try it right here. And then we're going to grab another one then for our inevitable problem 02. All right, so this one, just double clicking on there, that gets us our problem 01 and our problem 02. And the important thing to note is the function signatures. And so if you recall with both of these, they have an int return value and a void input argument. In other words, basically they accept nothing, but they return success or failure. Not a very interesting function from that perspective, but it did get the job done for us. So what we'll do is we'll go ahead and carefully go ahead and draw this over here. I'm going to go ahead and connect it over to the side a little bit. Again, we can work on the graphics later on, where our arrows are at and so on. But the important part is that we emphasize that void was passed to it and then back to our main. Again, wherever you choose to go ahead and have that connected, we'll improve on this later. That isn't the goal, is going to be an int. And the int was for success or failure. Let's see if I can at least get this out of the way. Looks reasonably decent. We'll probably just leave it at that. Looks pretty good for a start. Now, the main then turns around and calls problem 02. And again, we're not worried about any logic here. I'm not interested in that. I'm just showing you sort of the hierarchy of how these two compare and how they are visually different. Again, this is going to be a void for the input argument. In other words, it's not accepting any input arguments. And problem 02 simply returns. Let's see if I can get my arrow to go correctly. There we go, close enough. And again, clean it up a little bit later, but it already looks pretty good. So there we go, we have our int return value. Now, problem 01, well, it does nothing more, right? In other words, we've reached the terminus. That's as far as we go. And if you need a reminder, you can just go over to your code one more time and revisit what problem 01 does. It has all the inputs, the scanfs and the printfs, as well as the table, all inside the function. So for lack of a better way of putting it, it's essentially a dead end. In other words, it only communicates with main. Problem 02, on the other end, does not. In other words, it leverages multiple functions. As a matter of fact, what I'm going to do is I'm going to go ahead and drop all of them here. And this is where I'm not sure exactly how we're going to draw this out to make it look nice. Again, we can spend a lot of time playing around with this, but I'm going to try to get all four of these on here horizontally. We'll see how it works. Again, this is just meant to be more of a visual representation of how this program works. And then what we'll do is very carefully start drawing in our arrows. There's our first one. Tell you what, we'll leave that there for right now. And then again, we're going to be spending quite a bit of time playing around with this, and I have the feeling. And ultimately, let's see if we can't. Tell you what we'll do. I can see an obvious solution here. Why don't I just go ahead and delete these real quick, and I'm actually going to move these down just slightly, give us more room to play around with. And we're going to go ahead and just bring our problem 02 down. That way we don't have to worry about intersecting or hitting the problem 01. There we go, much better. And you can see that this right here is how our first function interacts with our problem 02. And if you recall, our first function was get box volume. And while we're at it, why don't we go ahead and label all of these? We have get cylinder volume. Probably not the best named one was our get difference volume, or get difference. And then lastly was our get quantity. So far, so good. Looks pretty good. What we need to do is we just need to now carefully go through and draw our arrows. Let's see if we can get a little more room on the side here. We can play around with these arrows to figure out how best to get them to interact. I'm not too terribly worried about that. Don't want to spend a ton of time on the video. Remember, again, we can do our control and the scroll to allow for us to zoom in and out pretty easily. And we can, of course, pan. Let's see if we can actually move this up one more time. There we go. Seems like it is just determined to turn our little arrow here. There we go, straighten that out, good. Again, the tool is pretty good, it's not perfect. There are some challenges. All right, so we're gonna connect that one now to the get cylinder volume, and of course, get cylinder volume gets called by our problem 02. And then if you recall from the code, then what happened is the get difference was called, and then the get difference returned. And then lastly, our get quantity was called. And let's go ahead and connect this one. And we can just bring this one up here and we can see if we can get this one to connect. That's close enough. Again, we'll go ahead and play around with the arrows. Surprisingly, given the fact that I'm doing this in real time and no editing on this, this actually has turned out a lot cleaner than I was expecting. All right, looks good so far. Now what we want to do is we want to talk about the input and output arguments. And again, if you have your little cheat sheet up, whether you're using NetBeans or in this case, I just copied it over to Notepad. Quick reminder, our box volume accepts length, width, height. You can go as far as to put the data types in there if you want to. Again, it's more about understanding the overall approach in this particular example rather than the details. So what I'm going to do is I'm just going to specify my length, and I'm going to hit Shift and Enter, which allows for me to put this down on another line here. Width, spelled, of course, correctly. And then height. And then over here on the return path is our box volume. And again, if you decide to use underscores instead of spaces, that's perfectly fine. If you want to rotate the text to make it look cleaner, that's probably also not a bad idea. It's going to get a little crowded here, but again, this looks pretty good already. For the cylinder, we have our height and our radius. And again, if you recall now what the return value is for the cylinder volume is, of course, going to be the cylinder volume. Again, however you wish to do that. If you want to rotate it, that's perfectly fine. The difference function accepts two arguments. First one is going to be the box volume. And the next one is going to be the cylinder volume. And those are your two input arguments for get difference. And for the output was essentially the unit or difference volume, whichever way you want to call it. Those were two different variable names. We'll talk about the scope of the variables. It was basically how they were known inside and outside the function. And then the quantity, or rather get quantity, accepts a couple of arguments: the bulk volume unit volume, efficiency, and then ultimately it returned the quantity. Now, the good news is we've got most of this pretty nicely set up. Looks like we're going to have a little bit of a problem getting those three in. Again, you could spend a lot of time playing around with this. I encourage you to at least spend some time. Once it looks good enough that it makes sense, you can go ahead and leave it. But the idea here is that hopefully you can visualize now how we have practiced our top-down or layered design here. So our main calls our problem 02, and you can see that it delegates, if you would, a lot of the behavior, a lot of the calculations to separate helper functions, which means that they could then be reused in other applications. So again, the goal of this particular video is kind of twofold. Is one, to show you quickly how you could diagram out visually what your code does in just a matter of minutes. Again, this turned out pretty good just for a quick attempt. You would obviously want to spend some more time improving it. This could also demonstrate to a non-technical user what your application does. And then the second reason, of course, is for us to understand and appreciate the benefits of our top-down design. And also, if you go back through our earlier video, you'll see how we could have actually built these little helper functions first before we even had a chance to build our program _02, problem _02. Again, there's some benefits to whether you build the smaller pieces first or the larger pieces first. Again, each application or each scenario might be a little different, but it's more of thinking in terms of a structured approach to building then this hierarchical set of functions. So as always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.